Thanks a lot, everybody, for joining us for this session. It's a bit late, so I hope everybody still has enough energy. It's going to be a demo-heavy session, but we will try to make it as much as possible, interesting and entertaining. So yeah, let's get started. We wanted to talk to you about file-based applications using volumes in Unity Catalog. I'm Adriana. I'm one of the product managers at Databricks. And I've been part of the journey of introducing volumes in Unity Catalog from the very beginning. And with me is Adrian. He's one of the engineering leads at Databricks. He has extensive experience with file systems and with object storage. And as you will see in just a bit, those are very useful skills, very useful knowledge when it comes to working on a feature like volumes. So yeah, let's get started. Before we get into the demos, we wanted to give you a bit of a on what volumes are and their main capabilities. So let's dive right into that. So what are volumes? Well, with volumes, we are addressing one important challenge in Unity Catalog, which is the governance of non-tabular data. And you might ask, if you have not heard about this topic before, what is non-tabular data in the first place? And the answer is quite simple. It's collections of directories and files that can be of arbitrary formats. It could be PDFs, it could be documents, it could be XML, it could be images, it could be even Parquet files. So loose, arbitrary files, which also need governance, like everything else in Unity Catalog and on the Lakehouse. So for the governance of these types of data, we've introduced volumes as a new and dedicated type of object in Unity Catalog. Now, as you can see here in the image, volumes contain files. And these files reside physically in cloud object storage. So in that sense, you can see volumes as a logical unit of storage to interact with these files. Of course, since it's a dedicated object type, you can use volumes to define permissions. And you can do so using user interfaces like you see here on the screen, but you can also do that via different APIs. And here we have some examples of doing that in SQL, but of course that's not the only option. You can also use REST APIs, Terraform, you name it. Of course, it's also everything supported in our SDKs. The idea is, as a person with the permission to create a volume, you can create a volume, you become the volume owner, and then can grant other users the ability to read or write files as part of these volumes. One important detail that is present on the image is also that there are two types of volumes, and we will see all of this in action. You have managed or external volumes. A managed volume will store its files in a default storage location for the schema that contains that volume, whereas an external volume is a volume that stores its content in a location that is defined when you create the volume. And that can be quite helpful if you already have perhaps files residing somewhere in object storage and you want to make it available in Unity Catalog and benefit from Unity Catalog governance. But that's not all. So volumes are not only about governance. That's really important, of course. But volumes are also about allowing you to work with files. So for example, to process files as part of different workflows that you might be running. So in that sense, we can also see volumes as a convenient way to work with files in your preferred way. You can work with user interfaces, and we've actually put a lot of effort in also providing a user-friendly experience in sort of just browsing the content of volumes, but also, for example, uploading, downloading files, creating, deleting directories, and so on. Just as well, there are many different APIs that you might want to work with when it comes to processing files, and those are supported when it comes to working with volumes. So for example, you can use volumes in combination with Spark APIs. You can also use volumes from SQL. You can also use bash commands or also local file system libraries, which could be quite useful, for example, in the ML space, where everything needs to be like local on the cluster node, on the cluster machine. What is really important when it comes to this file-based processing is that the Unity Catalog governance is still applied. So if you do a direct file path access, for example, to a catalog that you don't have access to, then that path access will fail. And this is hinted at also with the path choices that we've made. So the path that you can use to address files in the volume actually reflects the hierarchy of catalogs and schemas that hold the volumes, really to make it clear that governance applies. That's not all. Over the past year, roughly, we've put a lot of effort in making it so that volumes are seamlessly integrated across the platform. So you will see that volumes are part of the Lineage graph, for example. Usually in the beginning of the Lineage graph, because typically that's where you start your ingestion journey, for example. Just as well, volumes are part of delta sharing. So you can actually do delta sharing of volumes alongside notebooks, alongside models, alongside tables, and so on. You can also use volumes in combination with jobs to configure file arrival triggers. So basically trigger automation as soon as you have new files arriving into a volume. You can also use volumes as a source to configure your cluster libraries or, for example, jobs dependencies. And also, as part of user interfaces, we have these wizards that are very convenient to create tables. Well, that's also available from files that are stored in the volume, so you can point and click, select a few files, and then run this handy wizard that allows to create a table. Of course, there is much more to say. We will see a lot of this also in action. But one thing that I really wanted to stress out is that all of these are audited. All of the interactions are audited. So anything that you do with regards to volume or with regards to its content is part of our audit logs, which is available, for example, as a system table. And of course, there is also handy information schemas that you can work with. So that's going to be making it possible to use volumes for a wide range of use cases. Very often, we hear that customers like to use volumes for their ingestion pipelines as a starting point. So for example, as a staging location for files and then kind of kickstart complex processing as part of their ingestion pipelines. You could also use volumes for machine learning to run processing on large volumes of unstructured data, for example. We will see a bit of that in action today. So you could process, for example, images, audio, video, documents, and so on. We will also see in action how you could use volumes as part of CI/CD to some degree, or also as part of logging and checkpointing. So there is a wide range of use cases that you can hint at, or we are hinting at with this image. But yeah, let's see some of this in action. So we have two demos coming up, one using volumes for an AI use case and one for ingestion. And let's start with the first one. Let's go into some AI applications. We thought, let's make that a bit interesting. Let's take a scenario that we are familiar with. So actually, we took a scenario from Adrian's life. And what you need to know about Adrian is that he likes at least two things a lot. One, he really likes board games, so much so that he gets the latest ones as soon as they are available. And then he also really likes technology. So for example, he really jumped onto the bandwagon of working with LLMs. So for example, the way he embedded that in his life is whenever he has a gaming night, he likes to kind of refresh his memory about the instructions of the board games he's playing. And for example, just using out of the box LLMs out there, they do a quite decent job. For a game like Catan, which is quite popular, an LLM trained on publicly available documentation will give very, very good instructions. The problem is that Adrian really likes the latest board games as well, and these LLMs will not know about these latest board games because the instructions will probably not have been readily available. So here we have an example, Black Forest, and if you kind of read the instructions or the answers, you will see that it's actually a hallucination. So what we will show you live is that very quickly we can start off volumes to specialize such a model with information extracted from unstructured documents, from unstructured data, and then get in real life up-to-date answers with information from these documents. So it's a bit more complex than 3 steps. There are a few additional components involved, and I have this diagram that I'll use to sort of guide you through the overall process that you will see actually live as a demo. So of course, we will use a volume. We will upload instructions about board games to this volume. And then we will want to extract from these PDFs images and text. And we will want to use these images to kind of give also livelier answers. Here it's a bit dry, it's just text. Let's try to use some images as part of the answers as well. And also let's make the answers more credible by providing links back to the source documents. So for that, we will extract the images and we will put them back to the volume. We will also extract the text from these PDFs, and we will take the text through a few additional processing steps. We will want to extract chunks, and then from those chunks, embeddings. And for that, we will use an out-of-the-box model available in Databricks in model serving called BGE. That's a model specialized for working with embeddings. With those embeddings extracted that way, and also pointers back to the files in our volume, we will create a delta table. And again, using out-of-the-box capabilities in Databricks, we will sync this delta table with a vector database. And that vector database, together with the vector index, is actually the key ingredient to providing live answers to our end user finally. Whenever a user will ask a question, we will extract embeddings for those questions. We will do a similarity search against our vector index, and then extract the chunks that we have in our database. And together with the chat model, again, available in Databricks out of the box, we will provide well-formed answers to our user. I hope that's not too complex. Adrian will take us step by step through all of this. But what we will want to do as a final step is turn all of this into an automated process. So we want at the end that every time we upload a file to a volume, all of this runs automatically, and for that we will use a job. So with that, I'll give it over to Adrian to actually show all of this in action and also how our LLM actually works.
Thank you, Adriana. Let me begin by showing in action this baseline LLM from a couple of slides back. So here it is. Just a simple UI in front of just a few lines of code in a Databricks notebook, calling into the out-of-the-box DBRX model. Super easy to put something like this together on Databricks, and it's also quite powerful. For example, if I ask it a basic question about Catan, such as how much lumber do I need for a settlement, it's going to give me this accurate and to-the-point answer. I can also ask it something about some other popular game like Pandemic, and maybe a more open-ended question like, how do I win? And again, it's going to do well. However, there's a bit of an issue, like Adriana mentioned. So imagine my good friend Bogdan comes over one night and brings with him this fresh, top-trending board game called Harmonies. You can see it here on BoardGameGeek.com, along with its official rulebook and all sorts of other geeky details. Now, if I go back to my assistant and ask it about it, it's not going to know. It's going to hallucinate, and yeah, that's some room for improvement, right? And as Adriana said, we can also do with a bit more color here. So let's see now if I can give my assistant a hand by putting at its disposal a bunch of instruction PDFs, like you saw there. So I'll now be illustrating this initial part of the journey. For that, I'll begin with creating a volume. I navigate here to the Catalog Explorer, going to a particular catalog, and then Schema. And here there's this blue button that lets me create a volume. I have this choice here now between managed and external. And if, for example, I had a large collection of PDF files somewhere on a cloud storage path, I could just specify it here, and the external volume would be the best fit. But in my case, I just have a few files locally that I'm going to upload. So I'm therefore going to go with the simpler option of a managed volume. I'm going to pick a name for it. Let's call it collection. And then I'm going to go straight ahead and create an empty directory inside. Let's call instructions. And there I'm going to now upload some local PDFs. I have these 3 here now, but I'm only going to pick 2 and leave 1 for later. Now, here you see them being uploaded. And in a moment, I'll be able to browse the contents of this volume now, for example, by using this breadcrumb trail here, or by clicking into directories, just the usual. You also see here some handy metadata about these files, like last modification time or file size. Over here, we have some more metadata at volume level. You can see here who owns it, who created it, when, what's the storage for it. But maybe more interesting is this permissions tab. This allows me to share this volume with other users on my Databricks account. For example, I can find Adriana here, and I can share this volume with her with read-only access or read-write. But by default, this volume is going to be private to me. But now, by the way, if any of you in the audience would be interested in getting access to this volume, I could easily share it with you, assuming you have a Databricks account, by leveraging this delta sharing feature here. So I can click on delta sharing. I need to pick a so-called share. This is something I've pre-created to save some time. And then if I go here, I can add you as a recipient. And there we go. That's how I can easily share this volume, and perhaps also alongside other Unity Catalog entities, such as tables or models. So yeah, let me now change gears and move to a little bit of code that we use to process these PDFs. So for that, I'm going to be using this homegrown library called PDF utils. I'm going to go ahead and pip install it straight from a volume. And in fact, this is pretty standard practice for when you want to manage your own libraries. Let's say you have some jar files or some wheels. But on the other hand, you don't want to manage a private Artifactory. You could just use volumes instead for that. And then you have the UC governance and discoverability for libraries as well. Now, the processing for these PDFs that I want to do is to extract text and images, like Adriana said. And for that, I have this handy function in this library of mine, which does exactly what I need. You can see here it takes as input a path to an existing PDF file and some more paths for where you should write the extracted text or images. And yeah, it's pretty straightforward. Let's see it in action. Here, I would need to supply some path to a PDF. And to get it, I can make use of this handy sidebar navigator, Catalog Explorer. So I can browse into a volume all the way down to a particular file. And then I have this option here to copy the path, which is quite handy. I'll paste it here, and then I'll craft some more paths for the output. So let's say test instructions, txt, and test images. And I'll give it a go. As it runs, it's going to take a few seconds, but in the meantime, I can pick at its progress by leveraging this browser here, which shows me a bunch of images already. And yeah, looks like it's done already. And now, of course, apart from using the UI to explore contents of volumes, I can also do it programmatically. And for that, we can make use of this magic command, we call it, %fs. This is actually just a syntactic sugar over something you might be familiar with already, the dbutils.fs API. And that's typically used on Databricks to browse the contents of dbfs. And as you can see here, we have indeed made volumes available under this familiar file system, a dbfs file system or namespace, if you will. So what you see here are some URI-style paths, or more precisely, some Hadoop paths, which is what the Spark API surface interacts with. However, if you wonder about permissions maybe, then rest assured, Unity catalog governance is fully enforced and permissions are checked for these volumes every time you interact with these files. And now, if you are not so familiar with Databricks and you find this all confusing with this DBFS scheme, you can, for the most part, forget about it, disregard it, and omit it, because this is the default scheme on Databricks, and you can, it's going to safely be inferred whenever you don't specify it. But maybe one thing to keep in mind is that you sometimes have to make sure that you drop it, because whenever you need to interact with files on volumes in APIs that don't know about Hadoop, then of course that's not going to work like that. So you have to drop the DBFS scheme, and then it's going to work. So here you see the Python image library, how we can open an image directly from a volume. But maybe more typically, instead of doing that, if you want to embed images on a notebook, you would rather make use of this handy Ajax API endpoint, which gives you access to contents of volumes with browser cookie-based authentication. So with that, you can produce these handy hyperlinks that let you download files and volumes, or you can include those in HTML and put together display HTML commands like this that let you also scale the image, for example, and so on. So hopefully all of this gave you a pretty good idea about the basics of working with volumes and with files on volumes. But we spoke about automating all of this, right? So I will move on to that in a moment, but first let me clean up after myself. So I'm gonna just recursively delete this testing directory here. Okay, so now about automation. Automating the process of ingesting files and processing them, that's what autoloader was built for. Autoloader is this tool that we recommend for doing file-based ingestion in Databricks. It ensures incremental processing with exactly one semantics. It's super scale, not that it really matters here in our case, but what's more relevant is that it has full support for volume paths with all of its file detection modes. So both directory listing as well as file notification. Now let's see it in action. Here in this notebook, I'm starting with streaming data frame of format cloud files, which is another name for autoloader. And we point it at this directory on our volume where we store the PDFs. We're going to output the extracted images and text in the same volume, because we do want to keep these artifacts together with source files. But on the other hand, for the streaming checkpoint, we're going to use a different volume, because we don't want to mix our valuable data assets with execution state files. Moving on, the main processing that we do here is that we are calling the same function you saw before, but as part of PySpark UDF. So Spark executors are going to run this, and to make it a UDF, we just have to annotate it like this. And then the rest of what's happening here is that we're doing some string parsing and concatenation in order for us to construct some directory structure that conveys useful information or metadata about the files that we store there. So you can see here, we can tell whether it's an image or a text file, thanks to the directory structure, and then inside we have partitioning based on the board game name. So this could come in handy later on. Now moving on, looks like it's all done. So it's time for us to move on to this middle part of the journey here, which is about creating chunks and embeddings. For that, I've prepared this other notebook, which I'm going to run right away, and then I can walk you through it real quick. There are two main cells happening here, two main pieces of code that we're running. One is the generation of chunks as a UDF again. And as part of this, we are reading the text files that we created earlier from the volumes. And then we apply the splitter and we produce a list of documents or so-called chunks. Then we explode that output so that we produce a data frame with one row per chunk. We append a little bit of contextual information for these chunks, so namely what board game they belong to make it easier for the similarity search operation. Then we add a derived column for a unique identifier. And then later on, we add another column here for the embedding. We compute it based on the chunk, and to compute it, we simply call into this out-of-the-box BG large embeddings model. That's mainly it, and you can see here a sample of the data in this table. There's the source PDF, some metadata about it. There's the output text and directory for images, some more metadata. And then here is the chunk column. You can see an example here, just a snippet of text from that PDF. And then alongside it, there's the corresponding embedding, which is this numeric representation that's going to facilitate the vector search, similarity search operation. However, we have to keep in mind that we cannot just run similarity search directly against this delta table, but instead we have to set up a vector search index and serve it with an endpoint. Luckily, that's very easy to do. Now, if we go here to the table we've just created, again, we can navigate like this. We have the chunked instruction table, and we're going to open it in Catalog Explorer. Now we have this button here to create a vector search index on it, and we have to fill in a few details, like the name. Let's call it chunked instructions, vector search index. Have to choose a unique key for it, and a vector search endpoint, which I've pre-created to save some time, an embedding column, the size of it, which is 1024 in our case, and we're going to choose continuous syncing mode so that it's a little bit faster. There we go. We can see it here alongside the table, and it's going to take a moment to provision and sync. But in the meantime, we can finally move on to the more exciting AI part here, the building of the RAG chain. So now I'm going to move pretty fast here because I'm sure by this, by now, at this moment in the conference, you've all seen all of this before. You're familiar with the concepts, know what LangChain is, for example. So anyway, we will begin here with the same LLM from before, the DBRX. Actually, I'm just going to run this all from the beginning. Yeah, we have the same base LLM and a very similar prompt as what we used for the baseline assistant. But now we have this extra context clause here. And this placeholder is going to be replaced at inference time with a list of documents or chunks from that previous table you saw, which are relevant for the user query at hand. So namely for the question about the board game. And this similarity search task is going to be performed by the so-called retriever, which is nothing more than a wrapper or a client over the vector search index that we've defined before. Finally, we put this all together with these two lines of LangChain code. And then below, there's a little bit of code that constructs a HTML page. And we can better visualize that by looking at the dashboard here. So there we go. Here's our improved RAG assistant, which is now able to answer questions about this newly uploaded game, like harmonies. You see that it, in addition to the answer, it also provides the source for that answer, gives me a link to the PDF, as well as some nice image that's extracted from that PDF. I can also ask it about that other game I uploaded, which is Ezra and Nehemiah. And same story here. So that's pretty nice. Hopefully this is, thank you. Yeah, hopefully this is gonna come in handy for the next couple of times we play these games until we learn the rules by heart. But wait a minute, there was also this third game that I did not upload yet. I said I would leave for later. So that brings us to this final piece of the puzzle here, the job with file arrival triggers that's gonna make it such that as soon as I upload that PDF, everything's gonna be triggered automatically and the PDF's gonna be processed and the assistant is gonna become able to answer questions based on it without any further intervention from me. So let me now show you how this job that calls those notebooks would look like. Because normally I would go here and create a job, but I've done it beforehand to save some time. So here it is, just a simple job with 2 tasks, each calling one of those notebooks you've seen before, one for the PDF processing part and the other for chunking. And maybe the one thing to call out here in addition to this is that we specify a file arrival trigger. So here this path is pointing to my volume and to the instructions directory in my volume. And this will make it such that as soon as a file appears there, the job is going to be triggered. So let us do that right now. So I have here the directory, and I'm going to upload the third file. This is instructions for the board game called Black Forest. And once it's uploaded, it's going to take a moment for this to trigger and then to get processed. So I will use that time, so just a few minutes, to context switch and to tell you a little bit about this other common use case for volumes, which is for ingestion. Now, let's pretend for a minute that I put my workspace administrator hat on and that I set out to build a dashboard that lets me monitor what kind of libraries users on my workspace are adding to their clusters. So for that, I will ensure that all the clusters are configured with cluster log delivery to a particular bucket, cloud storage bucket. But more generally, or in your case, this could also be other applications that are like external applications outside of Databricks writing logs to this location. Now, the best practice for processing such logs is to create an external volume pointing to it, and then to set up a DLT pipeline that reads from that volume and creates a few tables, and then you can have dashboards pointing to those tables and answering the real business questions. So let me show you concretely how that could look like. Here I have this other schema for logs, and there's an external volume in there pointing to this particular location. And in there, if I browse the contents, you'll see that I have 3 directories. These are cluster IDs, so like 1 directory per cluster. And if I go inside, you'll see like directories for driver and executor logs. Anyway, to process this now, I would go build a DLT pipeline. Again, I have it pre-set up, and it's already running here. And if you look at this graph, it may seem familiar because this is the typical medallion architecture where you have some bronze, silver, and gold tables. Here, bronze table here is just raw logs. Then we have some silver table with parsed logs. and then maybe two goal table, one of interest being this library installation events. But in case this seems a bit daunting, if you're not familiar with DLT, let me show you how simple the code behind this is. It's just this simple SQL notebook with a few cells where you declaratively define those live tables. But I'm not going to look closely at them. I'm just going to focus on this first cell here, where we actually do autoloader again. But this time, we're making use of this more user-friendly interface. There's this cloud files table value function, which accepts the file format as an input here, and then obviously the path where it should read from. But notice how in this path, I'm specifying some stars. We call this a globed path. And it's actually a powerful feature because it allows me to selectively refer to only a subset of files in there. In this case, namely, I'm just looking at the driver log4j files. Now, if we zoom into this table of interest for our library install events, we can see here some sample data. So it's just a few events with timestamp and cluster ID and the library that was installed. But then it may be interesting to check out the lineage graph for it. We see here a nice graph with upstream and downstream dependencies. And if we expand here on the left, we will get all the way to that external volume that we started with. So volumes are fully integrated in the lineage capability of Databricks. We can also see here the downstream dependency. That is this dashboard for libraries. And this is what actually gives me the answer I was looking for. So you see, there's the Databricks SDK library that's the most common on my workspace. And then people seem to be doing more pip installs than local file installations. That's basically it about this. All I wanted to emphasize here is that it is very typical to have volumes at the beginning of all, at the ingestion step of DLT pipelines like this. But now let's go back to the assistant case to see if the Black Forest PDF was processed successfully. It looks like it was. It's all green there. So hopefully, if I go and ask it now about Black Forest, it's also going to be able to answer about it. And fingers crossed, yeah, there it is. It all worked automatically with just a drag and drop of that PDF. That's all I had. Thank you so much. Back to you, Adriana.
Thanks a lot. So, of course, there would be much more to say. We just wanted to give one additional input around the ingestion use cases. If there are some members of the audience who prefer to just use pure SQL, that's also possible. So, for example, there are these handy commands to put get files to a volume, just pure SQL. You can also list the files in the volume in SQL. You can also remove the files if you no longer need it. And, of course, you can run ingestion simply by running a copy into commands. All of these are supported with our SQL connectors, for example. So yeah, that's a bit on the ingestion use case. We are ready to wrap up. We are running out of time, but what we wanted to tell you is that you can use volumes for a wide range of use cases. And you've seen today how you can use volumes to kickstart a bunch of types of pipelines. You can use them for AIs, you can use them for ingestion, CI/CD, and of course, much more other use cases around file-based processing. As you do so, with volumes, you'll get unified governance. You will be able to govern both your tabular and non-tabular data. And also, hopefully, what you've seen today is that we've put a lot of effort into making it possible for you to get a streamlined developer experience across languages and across platform capabilities when working with volumes. You've also seen some handy features like this automatic syncing from your data sources to your application logic, because we've again integrated volumes with different platform capabilities. You've also seen how you can get end-to-end lineage from volumes up to even a dashboard as part of Unity Catalog. And again, just to stress something that I know for our customers is really important, all of this is audited. All of this is part of the audit logs. You've also seen a few additional details, like the fact that they are managed and there are external volumes as well. And also, we wanted to kind of point out again that the volumes are part of volume sharing. We didn't have the time to show that too much in action today. But with Unity Catalog, you get default access across workspaces at the metastore level for all the data assets. With volume sharing, on top of that, you also get access across accounts, across clouds, across regions. So hopefully that gives you some ideas around what you could do next for your workloads. And of course, if we have maybe some time, we can also take a question, or maybe we can just stay around at the end. Okay, so it seems we don't have time for questions, but we will be, both me and Adrian, around in case anybody wants to ask us anything. And of course, we are always happy to get also feedback. So thank you so much.